It is often very dark in color, having successfully suspended impurities, soot, and other byproducts of combustion. The appearance is often accompanied by a very characteristic odor. But let's turn our attention to new heavy-duty diesel engine oils and ask the question, what can we learn about oil quality by simply looking at the appearance and color? To any casual observer, it's easy to see that they vary considerably in appearance and color. But does that variation in color tell us anything about the specification and performance of the lubricant? To help us answer this question, let us consider three oils of very different quality. One is an ultra-high performance 5W30, meeting ASEA E6, API CJ4, and major OEM specifications. One is a super high performance 15W40, meeting API CI4, ASEA E7, and the other is a mono-grade API CD engine oil. Although they vary in color, it is important to note that none of them were formulated to meet a specific color. They were all formulated to meet a range of industry specifications demanded by the end user. Let's examine what constitutes a diesel engine lubricant. Irrespective of oil quality, every multi-grade engine lubricant contains three major constituents, namely the base oil, the viscosity modifier, and the additive package, sometimes referred to as the performance package. As per the illustrated example, it is usual for the additive package to dictate the color of the finished lubricant. So let's take a closer look at the additive and the components that constitute a heavy-duty diesel package. The first point to note is that the amount of additive in an engine oil relates to the target specification. As a general rule, the higher the performance, the higher the treat rate of the additive package. Clearly, this can have an impact on the color of the finished lubricant. However, if we've established that the color of the additive package is a key parameter in delivering the finished oil color, an examination of the components that make up an additive package is also a key consideration. Components are carefully selected to provide specific properties to an engine lubricant in line with the specification profile and performance level. In a modern lubricant, there is often more than one component from each family. Therefore, a high-quality heavy-duty diesel engine oil can contain a high number of components, all carefully selected and balanced to provide outstanding performance to the end user. For example, antioxidants are added to prevent harmful byproducts of oxidation, such as engine sludge, and to help extend the life of the oil. Detergents are added to protect the engine against deposits and to impart TBM, therefore preventing corrosive issues in the engine. During engine operation, a key concern is wear. Clearly, it's the job of the lubricant to provide wear protection. To this end, anti-wear chemistry is a key component in any engine oil formulation. Once more, the formulator may choose to use a number of different anti-wear components depending on the level of performance required. One of the most important components in a modern diesel engine additive package is the dispersant. Its function is to protect various engine components against soot agglomeration and other aspects of engine cleanliness that seriously affect performance and durability. Dispersants can vary in chemical makeup, and therefore colour may also vary. The experienced formulator may determine that a number of different dispersants are required to produce an engine lubricant that delivers the optimal performance to the end user. After all, they are formulating not to meet a colour, but to a technical specification and to achieve a specific